Good morning, mathematicians. We're looking at number 5 on this, and this one can be tricky. So really take a look at what it's asking us to do. When you break it down, it's really just asking us to round, which we can round, but certainly this is written in such a way that it does make us stop and ponder it for a minute. So really break it down and realize what we're going to do is round it to the tens place and then we'll round it to another place value. Okay, so let's start with the tens place. I know that all of these numbers are going to be cut off after this place value. But before I cut off the 9 and the 5, I consult this digit and I see, does this have enough power to raise this up and round it up, or will it round it down? Right? Well, we know this is going to round up. When this rounds up, instead of 10 and 9 tenths, we're actually going to have 11 and 0 tenths because the 9 rounds up to a 10, right? We know this. We've seen this so many times. Now, boys and girls, we have a 6 here in the hundredths place, which again is going to round this up because it is closer to being 11 and 1 tenth than it is 11 and no tenths. Now, let's take a look here. Does 5 have enough power to round the 7 up? Absolutely. So this will also become 12 and 8 tenths. It's going to round up like the other two. This one, the 9 does have enough power to round the 5 up. So this is going to become 13 and 6 tenths. Now let's take a look at this one. This 0 does not have enough power to round this up. Instead, this is going to remain a 9 in the tens place. And remember, we lose everything after that value because I'm rounding to the tenths. Now, the other place value that I was being asked to round to was the hundredths. I'm going to shorten it there because certainly, guys, this is my scrap work. This is my thinking that's going to lead me to my correct answers. But on your test, certainly write all over that test as it helps you. This is our moment to shine, mathematicians. So we're looking at this digit. Does 5 have enough power to bump this 9 up? Absolutely. But if this bumps up to a 10, it actually bumps this up to a 10, which actually means this is the place value. That's going to feel the bump up. These are going to get zeroed. So really, this is going to become 11 with nothing in the tenths like we had over here, but also nothing in the hundredths. Do you see why? Think about it, guys. If this was $10.99, would it be closer to being $10.99 or being $11 if we really were halfway to another penny? Here, of course, we would round it up. It would be $11. So now let's take a look at this one. We have a 1 in the hundredths place. Does that have enough power to bump this up and round it up? It does not. It's going to round down. We're going to lose a hundredth, and this is going to become 11 and 6 hundredths. Now let's take a look at this one. This 5 does have enough power to round this up. So this is going to become 12 and 76 hundredths. Now let's take a look at this. This 8 has enough power to bump this up, but because this is a 10, it's also going to bump up this place value. Now, this place value can receive it. It's not like this where we had to go all the way to the ones. So here we are going to end up with a 13 in the ones place. And this is actually going to become, instead of 59 hundredths, it's going to become 60 hundredths. That's looking similar. Now let's come down to this. 7 does have enough power to bump this up. And when it bumps up, we're going to have 18 as our whole number. We're going to have 91 in the hundredth place. Now, are these exactly the same? No. Are these exactly the same? They are. I know that this value and this value are equivalent values. These two, not the same. These two, not the same. These two, equivalent values. 10, or excuse me, 11 and 0 tenths is the same as 11 and 0 hundredths. These are equivalent values. Boys and girls, that is why we should select A. That is why we should select D on this select to problem.